Okay, we're going to have a look at a little bit of a different simple harmonic motion question here. We've got a particle moving with simple harmonic motion, and it has displacement given by this equation: x is equal to 5 cos 3t plus 2 root 6 sine 3t, and we want to find the amplitude and period of motion. Now, if it's moving with simple harmonic motion, we know that we can express the displacement in this form here: x is equal to a sine kt plus alpha. Okay, where a is the amplitude, k is related to the period, and alpha is sort of some phase shift, or if you like, the initial position at time equals 0 of the particle. So if it is moving with simple harmonic motion, it means that this should somehow be able to be converted into this form here. In other words, you've got a cos term and a sine term. You want to change it so that it's just got one single sine term. Before we go ahead there, for another time, we could look at proving that this does give simple harmonic motion, where simple harmonic motion is such that the acceleration is proportional to the displacement, and the negative meaning that it's in the opposite direction of displacement. So we could go ahead and differentiate this 2 times to get acceleration, and then show that acceleration is in fact some scalar multiple of the displacement itself. Okay, but what we're trying to do at this stage is we just want to change this expression into one similar to this. Now, to do that, what we can do is use one of our trig identities. So I'll just write that out. Sine of a plus b is equal to sine a cos b plus cos a sine b. So what we can do here is that if we look at the 5 here in the 5 cos 3t, if we can change that 5 into a sine here, and also the 2 root 6, change that into a cos, then what we can do is change this expression here back into an expression that just has a sine in it rather than a sine and a cos. Now, to do that, we do something a little bit different, I guess. We use a right-angled triangle and just use an arbitrary angle for in the right-angled triangle. So I'll just draw that here. There's a right-angled triangle. And we just pick some arbitrary angle. I'm going to call it alpha. And then with the coefficient of 5 here, because I want that to be a sine term, I'm going to put that on the opposite side, opposite to alpha. And the 2 root 6, I'm going to put that on the adjacent side, with a mind to making that a cos term. Now, with our right-angled triangle that we've made up here, we can then go and work out what the hypotenuse is. Remembering hypotenuse will just be the square root of 5 squared plus 2 root 6 squared. So doing that, we get our hypotenuse, which will be 5 squared, which is 25. That's pretty easy. And then also we've got to square this one here. So the square of square root of 6 is just 6. The square of 2 is 4. So we get 4 times 6 plus 24. And that's worked out kind of nicely. So it comes out to square root of 49, which is 7. Okay, so what that means is that sine alpha is equal to 5/7. So we then go back to our original equation here, and we just change it up a bit. So the 5 here, I'm just going to divide that by 7, so I get a sine alpha, sine being opposite over hypotenuse. So we end up here with, I'll squeeze it in over here a little bit, x is equal to 5/7 cos 3t plus our 2 root 6, we put that over 7. So the reason we put it over 7 is so that we generate cos alpha. Cos alpha is equal to adjacent over hypotenuse. So 2 root 6 over 7 of sine 3t. Now we can't obviously just go through and divide these coefficients by 7 without changing the equation. So to balance things up, we just need to multiply that whole equation by 7. Okay, so at this stage here, we can then go back to our displacement equation and say that 5/7, well, if this is alpha here, 5/7 is in fact sine alpha, opposite over hypotenuse. So we've now got 7, open brackets, sine alpha cos 3t. And again, the 2 root 6 over 7, really that's just cos alpha. So here's alpha adjacent over hypotenuse. we've got plus cos alpha sine 3t. Hopefully that's making sense. At this stage here, we've now got our trig identity here, and we can then say that the displacement x is equal to 7 sine alpha plus 3t. Okay, you can see here that we've got to an equivalent expression here, or equivalent equation of this form here, which is what we're after, so we can identify amplitude and period. Okay, so I'll just draw that, I'll just change that a little bit so that we've got our sine 3t coming first. Okay, and from there we can identify our amplitude. So amplitude of motion will be equal to 7, or 7 units. There's no units in this particular question given, so we'll just say 7 units. And our period, sometimes we use capital T for period, is equal to 2 pi over k, where our k value in this case is 3. So we have T is equal to 2 pi on 3. Okay, so in terms of this alpha here, you might think, well, what is this alpha here? Alpha is really just where the particle starts. It's sort of the time starts, I guess. You can work out that value for alpha quite easily as well, just by using our right-angled triangle here. So sine of alpha is equal to 5 on 7. We could just do an inverse sine to come up with the actual angle, which would be really just the distance, the distance from the origin that the particle starts moving from. Okay, there it is.